Hello, Algebra 2 students, and welcome to your first flipped classroom video. We are going to talk about the fundamentals of algebra, and today we are going to just focus on vocabulary and solving equations. You need your composition notebooks to take notes, a pencil, and you may need a calculator towards the end of the video. All right, so here we go. We are going to start by talking about properties of real numbers. The first property of real numbers we are going to discuss is the associative property. The associative property changes the way the numbers associate with each other or are grouped. So if we have three numbers, let's use letters in place of those three numbers because it can be any number in the world. It could be a 5, it could be a 3, it could be a 7. So we're going to use variables A, B, and C. A plus B plus C. And if I group the A and the B, that will give me one answer. And that would be equivalent to A plus B plus C if I grouped B and C together. So those two expressions would be equivalent whether I group the A and the B together on the one side or the B and the C together on the other side. That is the associative property of addition. Okay, now there's also an associative property of multiplication. And as you would guess, it just uses multiplication instead of addition. So if I took A times B times C and I grouped A and B together, that would be equivalent if I took A times B times C and grouped B and C together. So the associative property is basically saying that if you group the B with the A or the B with the C, no matter how you group them together, those two sides should be equivalent. All right, the commutative property. The commutative property says, I'm going to change the order. So if I take A plus B, that should really equal the same thing as if I used B plus A. Now let's try a real life example in this case. 4 plus 5 is 9. 5 plus 4 is 9. No matter which way I put it, 4 first or 5 first, I still get 9. That is the commutative property of addition. I'm just going to abbreviate addition. Now multiplication says the same thing. If I take A times B, that would be the same thing as B times A. Okay, and that is the commutative property of multiplication. And if you need to, again, I'm going to abbreviate multiplication with MULT. But if you need to, you could plug something in, like 3 times 2. 3 times 2 is 6. 2 times 3 is 6. So no matter which way you have the order, it's equivalent. The next one is the identity property. And if you think of the word identity, you know, you're trying to keep yourself the same. You're maintaining the same number. You want to keep it identical. So for identity property of addition, what would we do? If we had any number, 5, 6, A, what would we add to that number so that it stays an A? Well, we would add 0. Adding 0 keeps us identical, keeps the numbers identical. In identity property for multiplication, what would I need to multiply by so that it would stay identical? I would multiply by 1, because anything times 1 is itself. 100 times 1 is 100, etc. All right, the next property is the inverse property. Well, the inverse property says we use inverses. So the opposite of adding is subtracting. The opposite of multiplying is dividing. So we're talking about what would be the inverse property of addition. For addition, any number Then add the opposite. The opposite of adding is subtracting, or the negative. So a plus a negative a, that's a minus a, or a subtract a, that all means the same thing, would be 0. For multiplication, the opposite of multiplication is dividing. So we'd multiply by what's called the reciprocal. The reciprocal is taking it and flipping the fraction so the denominator is in the numerator is in the denominator. The a's would cancel and you'd be left with 1. That's the inverse property, canceling it out. So that's the inverse property of multiplication. All right. The last property is the distributive property. And it says we multiply or distribute to all terms, to several terms. So if we have a times b plus c, now notice this has multiplication and addition in there. The addition is within the parentheses. That can also be a subtraction. But it could not be a multiplication. So that either has to be addition or subtraction for this to work. And you should all have seen this in Algebra 1, where you take a times b and you get ab. You take a times c and you get ac. And that would be the distributive property. Other vocabularies that we want to talk about is what is an expression. An expression is an algebraic statement with variables and numbers. Remember, it does not contain an equal sign or an inequality symbol. So, an algebraic statement would be x plus 5, 3x squared minus 5x plus 2. Those are all expressions. Those are all algebraic expressions. You can also have a numerical expression. Take the number 5, that's a numerical expression. In any case, those are all expressions. They do not have equal signs or inequality symbols. An equation. An equation is an algebraic statement. It actually says something. It says that those two expressions are equal. So if you take two expressions and set them equal to each other, that is an equation, okay? Another equation could be 2x squared minus 3x equals 7. Those two expressions equal each other. They contain an equal sign, and you can solve them to find the solution. So we can figure out what x equals, and we'll be doing that at the end of the PowerPoint here. An inequality. An inequality is an algebraic symbol, or excuse me, algebraic statement that compares two expressions as well, but it's not an equal sign. We use descriptions such as is less than, is greater than. So is less than, is greater than, is less than or equal to, is greater than or equal to. And these are the inequality symbols that we would use. Okay, so I could say 3x minus 7 is less than or equal to 20. That would be called an inequality. All right. We have two types of numbers. The real number system. In the real number system, we have rational numbers versus irrational numbers. Okay, and to take a closer look at what these rational and irrational numbers are, I thought a diagram would be the best way to talk about these. So here are the real number system. And you can see that they're broken down into rational numbers and irrational numbers. Within rational numbers, you have some subgroups. Okay, I like to start with the inside group. those are your counting numbers. Like I would count some books, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It doesn't contain 0. Okay, they're your counting numbers. Then when we go from the inside out of the rational numbers, we would then go to whole numbers. And whole numbers then include 0. So then 0, 1, 2, 3, 4, 5, 6. Okay? And then once we go further out, we say, well, there's integers. And the integers are negatives now. So -3, -2, -1, 0, 1, 2, 3. And then all rational numbers would also include a number that can be written as a fraction. A number that can be written as a fraction. Okay. So if I can write the number as a fraction, it's a rational number. Or maybe I can write it as a terminating decimal or repeating decimal. So in this case, this is a repeating decimal. And then a terminating decimal would be like 0.75, which can also be written as 3/4. So rational numbers include counting numbers, whole numbers, integers, and any numbers that can be written as a fraction. Or I could also say ratio. I like the word ratio because ratio is within rational. Okay, and then that includes your terminating decimals, which can be written as a ratio, and your repeating decimals, which can also be written as a ratio. Then the other set of real numbers that is not included within the rational numbers is called irrational numbers. And irrational numbers are numbers that cannot be written in fraction form or in ratio form. They go on forever and ever and ever. They never repeat. They never terminate. They just keep going like pi, 3.1415926535897932384. It just goes on forever and ever and ever. Same with the square root of 2. If you put that in your calculator, it'll go on forever. Nothing will ever repeat. It won't terminate, and you can't write it as a ratio. Those are the two types of real numbers that we needed to talk about. Now we are going to go ahead and do the solving part of the PowerPoint. And so we are going to learn to solve. Now, to solve means to find the solution or solutions of an equation. To find the value that makes the statement true. When I plug that number into my equation, will it make it true? That is what we do when we're solving. Okay, so we are going to solve example 1, which means we want to get x alone. Okay, there's a few things we need to do here before we can get x alone, though. First, we need to use the distributive property. 3 times x is 3x. 3 times 4 is 12. -2 times x is -2x. -2 times -5 is +10. So here we did the distributive property. We are using this property to do the first step of our equation here. All right, now, what would be the second thing we do? Well, I want to get the x's alone, but they're on opposite sides. They're not even on the same side. So if they're not on the same side, because we have this equal sign in between them, we have to do the inverse operation to get them to the other side. So if I want to get the 2x to the other side, I have to do the inverse operation. So the opposite of subtracting 2x would be adding 2x. Once I add 2x, I get 5x plus 12 equals 10. So what did I do there? I added 2x to both sides. All right? Now I have my x all by it. Well, I got my 5x over here, and it's kind of by itself. But I want to get the 5x alone so that I can ultimately get my x alone. My goal is to get x alone. So I am going to subtract 12 on both sides. And I will be left with 5x equals 10 minus 12 is negative 2. Just making sure that I'm doing my math here correctly. Then I want to solve for x. So to get x alone, those two things are being multiplied. If you don't see the multiplication sign, it's multiply. You know, we have to see the addition sign or the subtraction sign or the division sign. And the opposite of multiplying by 5 would be to divide by 5. And so the answer would be x equals negative 2/5. Now you could substitute that back up into the equation to verify that you have the correct answer. Okay, moving on to the next one. And once you did check that answer, you could circle your answer. Always checking to make sure that you do have the correct answer. Okay, example number 2. Example number 2 says 3x plus 2 times x minus 3 is 24. Again, we have to use the distributive property. 2 times x is 2x. 2 times negative 3 is negative 6. Bringing the rest of the problem down. Oops, I missed this positive sign there, the addition sign. Make sure you bring everything down. And now we are going to solve for x. Oh, now this one, the equal sign is here, and the 2x and the 3x are on the same side, and if they are on the same side, we can combine like terms. Only if they are on the same side. Okay, so 2x plus 3x is 5x. Minus 6 equals 24. Going to try to get that x alone again. So I want to add 6 to both sides. I get 5x equals 30. Divide both sides by 5. And I will get x equals 6. Excuse me, I'm dividing by 5. And we're not dividing by the x, we're dividing by 5. So we get x equals 6. Now, you would plug that in and check it out, make sure that it works back in your equation before saying that that for sure is the solution. We want to make sure our solutions make our equations true. All right, that's it for now. We'll see you tomorrow.